Hello, welcome to our video solution to problem 8, the final problem from Superquiz 2. And in this problem, we want to compute a line integral, but we want to take the easy route. We want to use the fundamental theorem of line integrals. So we're integrating a vector field f, but we're told not what f is, but rather what its potential function is. So we actually could, of course, get f by just taking the gradient of little f here. And then we're given a curve C, and we're even given the parameterization for it. So the important thing here is, well, one, this vector field is, of course, obviously it is conservative. This function f is continuous as we want it to be. The curve C has a lovely smooth parameterization, so we can absolutely use the fundamental theorem of line integrals. And what does the fundamental theorem tell you? Well, it tells you that computing this integral is actually going to be found by just taking f and evaluating it at the terminal point of the curve. And then subtracting the value of f at the initial point, or the starting point. So all we have to do is figure out, where does this curve end? And of course, that's going to happen when t is equal to pi. And where does it begin? And that's when t is equal to 0. So let's see here. So what is r of pi? So this will be 3 sine of pi e to the pi, comma 5 pi squared minus pi plus 1. And let's see, sine of pi, ooh, but that's actually 0. So the first component is 0, and the second component is, well, it is what it is, 5 pi squared minus pi plus 1. All right, so in order to compute f of the terminal point, we're going to be computing f of 0, comma 5 pi squared minus pi plus 1. Okay, how about the initial point? Well, the initial point, that happens when t is 0. And so we're going to get 3 times the sine of 0 times e to the 0. And then, oh, this is really nice, 5 0 squared minus 0 plus 1. That's just going to be a 1. And once again, we get sine of 0 is 0, so the first component is actually 0, and then the second component is 1. So we just need to now evaluate f at 0, comma 1. Okay, well, this actually isn't so hard to do. Let's see. The x component in each case is 0, which means the first two summands are going to be 0. So we're just going to get, for this first one, e to the, well, this monstrosity, so e to the 5 pi squared minus pi plus 1, and then minus e to the, well, 1. And there we go. So with just a little bit of substituting of numbers, recognizing that the fundamental theorem of line integrals, right, which is what we're using right here, is applicable, we're able to compute a line integral of a vector field in pretty short order.